Thank you. Thank you for your wonderful introduction. And today my presentation addresses this topic, quite peculiar topic, especially given the context of this fair, which is wood identification. Wood identification is a current topic because it applies to a number of different industry sectors and different types of products. Today we're going to talk a bit. So I'm going to show you the main methods for wood identification that are currently used, that are being studied and developed, by the way, and then we're going to focus a bit more specifically on how what you see in the tag there, so macroscopic wood identification, which is the most immediate and easiest method to use and apply to identify wood. So everybody can learn this method and use it. And it also does have some scientific foundations. Again, as I said, wood identification. First of all, what does it mean to identify wood? Well, identifying wood means assigning a name to a piece of wood. And a piece of wood can have different shapes, can be in the form of a number of different sub-products. So the most trivial example is solid wood. So solid wood. But then the need to identify wood applies to wood products. That's more complicated, where wood is reduced in more or less small parts. And so it may apply different types of wood-based panels, like plywood, or smaller elements, like cut wood or chipped wood. So particles, wood particles in MDF, wood particle-based panels. And you can have pellet used for making energy, or paper. So everything that is wood-based can be identified, recognized, in order to know what the original wood species was, and why. Why do we want to identify wood? The application fields for this discipline can be the most varied. Probably the first field currently, and the foremost field, is the legality of wood. So nowadays there's more and more search and work being done by research institutes the world over to find effective methods for identifying wood, especially for purposes of the fight against illegal wood trading. And according to Interpol estimates, the volume, the business volumes is 50 and $150 billion a year, and the illegal trade of raw materials is the most profitable of the world, really. And so this relates to, all other issues: climate change, preservation of ecosystems, of forests, and of all the services that these ecosystems and forests yield to man, to humankind. And all these, we're all going more and more in the direction of finding methods that that can be applied and are effective to identify possible cases of illegal trading. If we change field altogether with cultural heritage, I mean, we don't think about it, but it's very interesting, especially in Italy, where our cultural heritage wood-based cultural heritage is huge. I deal a lot with cultural heritage as well. And it's very stimulating field because in the past, ebony workers would use, or other craftsmen would use the most varied types of wood, local wood. And so we do find a variety of wood here that we don't normally find in modern wood business. And at times it's unknown wood because there's no commercial value in these woods. Another area is, for example, legal claims on wood supplies, because currently it may still happen, a few cases when there are doubts, concerns on the real identity of what is sold, marketed. So these are the three main areas where we do apply this discipline. And what does it mean to identify wood? It means giving it a name. We are used to using common or commercial names, rightly enough, because we use commercial names to identify wood. So mahogany, oak, chestnut. So it's all names that are related to common terminology, and they may vary from one language to another, and sometimes there are misunderstandings when switching from one language to another. And actually, when we are identifying and recognizing wood scientifically, so by means of a scientific analysis, the framework of reference, the nomenclature, is not the commercial one, even though there are reference standards, like for instance there's a European regulation identifying the main commercial woods with their pilot names. But actually in the scientific world we use the scientific nomenclature, the one invented by Linnaeus. For instance, Quercus petrea is the name of oak. Mahogany is a name that can be used for a myriad of different woods coming from very different geographical locations. Mahogany corresponds to two species of the genus Svetania. So I won't go into the details really, but again, this is just to introduce the topic of our workshop here. So we'll know what they refer to when we see the slides. So identifying wood scientifically means identifying the scientific name, which is the only type of nomenclature which is unique all over the world. So if I say Quercus petrea all over the world, we identify the same type of organism, the same tree, the same type of wood. Of course, the name of the wood, the scientific name of the wood is derived from the scientific name of the tree, or plant, where it comes from. So this is a unique, unambiguous standard that the only system we can use unambiguously to identify for certain a wood sample. Now, the question we are asked when we want to identify wood is, what species is it? The botanical species. So, as I mentioned, oak is Quercus petrea. There are three areas of science that deal with wood identification, and there are wood anatomy, DNA, and analytical chemistry. So the wood identification methods are quite a few different from one another, and they use highly different characteristics or properties to answer the original question. So anatomy of wood implies, or actually is the most ancient method used for identifying wood. So there's quite an extensive experience in this method, because it's been at least a century that scientists have been looking at wood anatomically. And what does that mean? They use the cell structure of the wood tissue to identify the species. And the anatomy of wood is subdivided into three methods. So macroscopic identification, microscopic identification, and machine vision. And the first two are actually the two faces of the same coin, because macro and micro identification use the same structure, simply at two different levels of enlargement. The macroscopic level is low enlargement, like a magnifying lens. Microscopic level does use microscopes, different kinds, biological microscope, electronic microscope, that does not matter. However, tools that allow us to reach the micron scale, so much more detailed scale. Microscopic identification always starts from and integrates macroscopic identification. So macroscopic identification is always done by the anatomist as well. And then it adds, he or she adds a number of information that can only be derived from microscopic examination. Machine vision, which is the third method here, is a recent method, just a few years. Researchers have been working on AI tools for wood identification that are based on the anatomic structure. So there's some research going on right now in terms of developing AI tools. We have a few already available, but they don't work very well yet. So we still don't have effective tools available, but the purpose is, using a smartphone. So you take pictures. Of course, you have to use certain orientations, angles, but you take pictures, photographs of wood, and the software program automatically identify wood for us. So it tells us what wood it is. So it's an evolution. You know very well that artificial intelligence is really being applied to all fields of human knowledge nowadays. So for sure, it will also give its contribution to the world of wood, giving us more and more user-friendly identification tools and more easy to use. The limits of wood anatomy is that oftentimes you don't get to identify the species. And given the vast experience that has been piled over the decades, so everybody is aware of this limit. So it's not an issue of adding research, adding information. It's exactly the way the system works. And of course, I won't go into the details here to explain in more details, but the way this system works, oftentimes you're not able to identify the species. So what does that mean? For instance, in the case of oak, by wood anatomy method, you can't tell it's Quercus petrea. It could be oak, or it could be something else. So I can look at it in the microscope, but I cannot reach certain level of details. So you can distinguish between English oak or other oaks. So this is a limit that cannot be overcome, and in many cases it may be enough to get to a level of detail that is less specific. In other cases instead, because of the legality of wood, you need the lawfulness of it. You have to be able to recognize the species, or not a group of species, or not just oak in general, but what kind of oak, so get to the Quercus petrea. So especially in the last few years, there have been other areas, fields, dealing with the wood identification in order to try and solve the structural limit of the anatomic method. And so we have genetic methods based on DNA and others based on analytical chemistry. DNA-based methods are very promising, because if I read the DNA, I can get to the species. So the accuracy I achieve there is extremely high. Wood is dead material. So the majority of cells making up wood die as soon as they are created by the tree, by the plant. There are very few live cells in a tree. Exactly because of their function, the majority of tree cells have to be dead. So, and then when wood is cut, dried, exposed to light, this very few DNA tends to decay. So extracting DNA effectively from wood is hard. Getting high quality DNA to be read and codified is even harder. So there are a whole set of limitations that make DNA identification hard and not so immediate. One thing is identifying a leaf where there's a lot of live cells, but it's harder for wood, and especially the older the wood, the harder it is to use the DNA method. So I won't go into the details of barcoding and fingerprinting, but there are DNA-based methods. Analytical chemistry uses spectrums, so mass spectrometry with that daft TOMS, DART, TOFMS, infrared spectrometry, and these techniques do detect spectrums. Then every tool, of course, instrument does have its different techniques, but the idea is to detect spectrums and correlate them to the specific imprinting or print of a specific species. So NIRS is also used for wood to estimate mechanical properties, for instance. It's very complex to use these methods, and then the conditions of wood actually affect the efficacy of these techniques, like moisture, for instance. So here too, extracting the imprinting, the print of the type of species gets harder and harder. All these methods are evolving, but they cannot be applied as yet. Lastly, stable isotopes. Actually, they're not used to identify the wood species, but the geographical location of wood, so the origin, geographical origin of wood. This is very useful for legal reasons. Think about oak drums. I mean, they come from France or from Eastern Europe, but the same species can be legal if it comes from one forest, illegal if it comes from another forest. in another country or region of the same country. So in the technique of stable isotopes that was taken from food industry is more and more being used in wood, again, to try and answer the question, where does this piece of wood come from, and not just what species is it. So again, the picture is very complex. So nowadays, 90% of wood identification is done by means of wood anatomy. So it's the least accurate method, but it's certainly the method that always gives you an answer. Then accuracy can be some variable, based on different variables, starting from the specific piece of wood we're trying to identify, but it's a tool that can always give you at least the first answer. The other methods can currently be used to integrate the wood anatomy method. So when you really need to have some more details, after the first anatomical examination, you can go further, and for that species that you think that the wood come from, there are gene-based techniques, and there are laboratories in the world that can do that specific type of examination for that species. So this is the situation right now, and we're moving forward, trying to both integrate these methods, especially gene-based methods and analytical chemistry methods, so that can be applied to more and more species. Actually, I was saying we'll deal with macroscopic identification. That's the most immediate method that we all can apply. Because for all other methods, we need specific instruments, equipment, and you also need a level of knowledge and experience which is quite high. You have to be a specialist. The macroscopic method instead is the method that allows anybody to be able to identify wood without being an expert. Or people who love wood can get passionate about it, and they can use this method. And it's a method that is taught to customs officers, CITES agents. They're on site and they have to check wood timber loads and see if there are concerns, illegal wood trade, cases of illegal wood trade. And it's a method that is applied professionally too. It's not like used as a pastime, but it's an internationally recognized method that does have a solid base, scientifically speaking.
What is the macroscopic wood identification based on? It is based on a magnifying lens, or, as you can see, on these USB small microscopes, which can achieve a remarkable enlargement sizes, or smartphone lenses, the one you see on the right here. So any instrument or tool that allows to enlarge our sample, not excessively. And identification is also based on a number of characters, let's say. There is a very long tradition in terms of wood anatomy. However, together with some colleagues a few years ago, we completed bibliographic review of different authors that had developed books, handbooks, atlases for microscopic identification. Some came from North America, South America, from Africa. So we looked at their characters, we identified what they were looking for, and we tried to unify their codification, their coding method. And so we have come up with this draft of standard list of characters to be used for macroscopic wood identification. We published this list on JAVA Journal. JAVA is the International Association of Wood Anatomists, and therefore it is the association of reference from a scientific point of view for whoever deals with wood anatomy. And then we translated it into Italian in order to be able to use it within our country. So there are a number of features, 106 features or aspects that we can look at in a piece of wood. More than 50% are anatomic features, and they are referred to the cell structure. We often don't think about this, but many elements of the wood cellular structure can be seen visibly with our eyes. When we talk about wood porosity, we are basically talking about wood cells that are large enough, for example, in hardwood, to be seen with eyes, and often in some other woods, such as in larch or poplar woods. These elements can be seen by with an enlargement sense. On oak, we have these decorative elements which can be seen on radial surfaces, and this element is strictly connected to an anatomical structure which is called parenchymal rays. So there are different structures that are really bound to the cellular structure or configuration of the wood. And so if you can observe wood in a correct way, you can already observe these things, these features, these objective features with simple eyes. These are objective cellular structures, so they are not an interpretation of how I see them, but these are structures, are elements that can be explained and demonstrated to any stakeholder. You can say, I can see this and say, I can identify this and this feature, and based on these findings, I can tell that this wood may be this or that one. A part of the other features are so-called non-anatomical features, and the first one everybody uses is color, for example. Color in wood can often be misleading as far as wood is concerned, because it suffers from alterations from light exposures, or because the wood itself is prone to alter. But color is, for example, a feature that is used depending on the wood. Color may be a more or less dependable feature to be used cautiously, but also the weight of the wood. And if it is evaluated to standard units of reference, can also be used as a feature to compare different woods. So there are a number of features which allow us to complete wood identification, at least at macroscopic level. What you see here are surfaces, cross-section woods, and the head of the wood, as we say normally. So most of anatomical features that are used for identification purposes are to be found on the head, on the end of the wood piece, the piece that we typically never look at, because we typically focus on the longitudinal surface. But as a matter of fact, these two pieces were prepared with a very thin sanding machine. We needed it to be very fine because of picture quality. But they can also be prepared with a very normal cutter. You just wet the surface slightly, and then you can clean with this tool just a few millimeters of surface, and you can observe the details of the anatomical structures. Do I have a pointer here? Let's see if I can use this stick to point to the pictures I want to comment on.
un puntatore non funziona,
Ah, non funziona.
Se è un normale puntatore non funziona, perché ce l'abbiamo anche noi, ma... Raggi infrarossi. Raggi infrarossi funziona? Proviamo.
Proviamo.
Let's see, maybe we found an infrared pointer. Let's see, let's try if it works.
Grazie mille. No. Grazie comunque.
Grazie.
Faccio vedere proprio brevissimamente.
So let's see if I can show you something very, very quickly with this rudimentary pointer, so to say. So what you see here are the pores detectable on the head surface of two oak woods. So Darmast oak and red oak, northern red oak. So there's a part of these pores is very big, and the other part is very small, and this is what delivers the effect, flame effects. We have two types of porosity inside of the very same ring, and one part of this is very compact and the other one is very, very large. So this gives a very clear pattern from a decorative point of view. Oaks are very easy to be identified with this method because they show a number of features that I cannot assess in detail. It would take too long. And one may say, well, oak wood, if you just have a good eye, you can recognize it, you can identify it without looking at the head or terminal part of the wood piece. Yeah, that is true, but the distinction between oak wood and northern red oak wood is much more difficult from an aesthetic point of view because we don't have objective physical elements that allow us or to our eyes to distinguish them with certainty. So, but by using microscopic identification systems, oak wood presents pores or vessels that are filled with these structures indicated by arrows, and these structures look like a cartilage, and they're called, they have a specific name, and if you look at them in red, northern red oak, you can see that they are either missing totally, completely, or very much present. Well, all of these pores on the right-hand side are all black, so they're not filled with these specific parts. And this is an objective criterion that allows us to distinguish these two species much better and more accurately than just by judging colors.
Molto più piccoli di questa parte dell'anello.
These are the much smaller pores of this part of the ring, and in the northern red oak they are very well distinguishable and visible, whereas in white oaks or the Darmast oak they have irregular contours and less distinguishable. So these two elements allow us to really make a distinction between the group of woods belonging to northern red oak from Darmast oaks and all similars. So this is an example that this is a very quick example of how the method is applied. Basically, we observe a specific set of elements which we can describe, objective elements, and based on the fact that somebody studied these woods and wrote somewhere in a manual that they can be distinguished by these elements, and then I can use this methodology. The difficult part comes to when we need to train our eyes to observe wood in a way that we don't normally do.
Per questo motivo
And for this reason,
stati in particolare nel tempo dedicato a
I took some time to work on certain atlases in Italian language, sorry. And up until 10 to 15 years ago, we had no tool available in Italian. These tools would be used internationally or in the United States. There were several atlases for macroscopic wood identification in English or other languages, but there was nothing in Italian. So starting from this list of features that I just mentioned, we first produced this atlas of Italian woods. It's depicted here on the left. It can be downloaded free of charge from the website of the region of Piedmont. It's an atlas with a software. Both of them, software and atlas, can be downloaded free of charge. It's an identification atlas based on the method I've just described, and it identifies the 48 top Italian woods, like local woods, but also northern red oaks or Paulonia woods that are grown.
diciamo un respiro molto più ampio.
And then, together with my colleague Lancrivellaro, I worked at this other atlas, which is available in English. Its scope is much wider. It's an atlas of microscopic wood identification for all main marketed woods in Europe. So it examines 135 woods coming from all over the world, and they represent the most important woods that are either imported or marketed within the European market. This atlas is also accompanied by its software with a license key, which we can talk about a little bit later if we still have time. And this atlas is available in English, though. However, there's something I would like to spend more time on, and this is the latest born in the family. I wrote this book together with Gianni Cantarutti, who owns a beautiful artistic xylotech in San Giovanni Latisone, near Udine, northeast Italy. And we put our competencies and knowledge together, and this colleague of mine provided the samples, objects, works of art by artisans, whereas I contributed with my technical competence and knowledge. And together we developed this atlas for the microscopic wood identification. And this atlas is something between the Italian atlas and the English one. It includes about 200 woods coming from all over the world, and they've been selected by a mixed criterion. So these are not necessarily woods that are commercially relevant, but these atlas includes woods that are really odd, curious, that played a major role in the history of art or in history, and that are no longer used or marketed because they are now part of cultural heritage, and they can no longer be sold or used. So our effort was to put together not just an atlas for microscopic identification, but something that provided some additional information. So something that could work as a cultural dissemination tool. So I have here an example of 2 pages of this atlas. These are the 2 typical pages describing a certain wood. The example chosen here is Bubinga. That's an African wood that corresponds to this species name, Guibourtia tesmanni. For sure, we're going to use the commercial name, which is the most popular. But it's also important to define the scientific name, because commercial names can be the most various one. The botanical genus so that the scientific name is a Latin word, and then the first part of this name indicates the genus. So all the oaks are part of Quercus, and then we have Quercus rubra, or Quercus petrea. Whereas in the case of Bubin wood, we have several other woods that are importantly that are economically relevant and commercially relevant, and this is explained in the introductory section of the Atlas pages. So we provide a general context for this type of wood and similar wood that can also be marketed. For example, here we mention some other woods coming from Africa, and these names are specified and listed in the second paragraph. Musibi on call, and which is also renowned as the Daniela walnut tree. And we try to contextualize this wood with all the closest family members. And then we also describe the trade context. Bubinga is often also mistaken for rosewood, but rosewood actually belongs to another genus, wood genus, and there are between 10 to 15 different wood species that played a major role in the course of history. Very precious bois de rose, bois de violette, and all famous types of wood are listed. So we try to set the context for this specific wood and some curiosity news, trivia news, and then there is the FSC symbol. When a specific wood is available in the FSC databases, is potentially present and is FSC certified, we then indicated it. It doesn't necessarily mean that woods are all in the FSC database, but this one is present in that database as a certified and available species. We then indicate the main utilizations for this wood. So we got this information from other sources, from other books, where woods are described also from the point of view of what they're used for. Then we indicate the geographical location. This is a locally grown, this is a type of wood that grows naturally, and when it is grown, then color yellow indicates the states, the countries where it is grown. For example, teak is present as yellow in Africa and South America because it's grown all over the world. And then in at the bottom part of the first page, we provide indication of the UCN status. That's the International Union for Nature Preservation. This is an international entity or organization whose purpose is to provide catalogs of all living species based on their risk of extinction. The UCN doesn't really correspond to an effective protection setup, but it gives us an idea of the risk this type of wood is exposed to, and also, consequently, its environmental sustainability. So the rating scale is an ascending one, and in this case, this is an endangered species. And the very last, in the very last part of the scale, there is a critically endangered step, and then after that, there is only extinct. And as you can see, this wood is not particularly sustainable as a wood species, especially if it lacks forestry certifications. And in order to understand the sources of critical points, then you can visit the UCN website, which specifies and details the main threats to this specific wood species, and it explains why this wood is categorized with this risk score. If we go to the right-hand side of the page, that's the technical data sheet. This is strictly related to macroscopic wood identification. At the top on the right corner, there is a cross-section picture of the wood and how it shows, how it looks. And you see a list of codes with some descriptions next to them. This is the macroscopic description of this wood. It's a very technical language, but this list is referred to the list published in Italian, which can be downloaded free of charge from internet. So it's a very small handbook of 10 to 15 pages, sorry, and you can use this to interpret this description with these codes. Then we have one part on physical and mechanical properties of wood, which supplements the information. We've used radar graphs, and for each of the characteristics like the MOR, MOD, hardness, and then we have the diameter of the typical wood log. Well, each of these values is represented by a point within this radar graph, and the position of the dot or the point indicates the position of the percentile against the entire population of this wood. So the outer the point is, the higher the value. The inner the point, the lower the value. For example, here we have a modulus of rupture and a modulus of elasticity, MOE, which are much higher than the average. We have a pretty high volume mass. We can't read it properly, so 920 kilogram per cubic meter. And this gives us an idea of the absolute value, but also of its meaning. Is it high or is it low compared to the average values? So just by first sight, you can really take a snapshot of the characteristics of this wood. A shrinkage value, radial, and for this wood, for example, we have a shrinkage rates that are in absolute terms quite high, but the ratio between the various types of shrinkages is pretty stable, as 1.4 is a value that is very much near the center. So this is a wood that doesn't tend to deformation. So deformation is pretty limited for this wood species. And last but not least, we have natural durability of the wood. So these are the strength classes by the Italian regulation. So resistance to insects, fungi, termites, permeability, and width. So we have a table with all the classes, and gross character indicates, bold character, sorry, indicates the class relevant for this wood. So it tells us whether it's a very resistant wood or not. And Bubinga is a fairly resistant wood. It shows a very good scores in terms of durability, all durability classes. Then we tried to supplement the whole atlas with pictures that would show some peculiar combinations. For example, specific slopes of grains, which can be very decorative, and so it's a very much coveted type of wood. You can see how this wood was used for a specific object. It's a table. These tables are designed by artisans and designers that are then listed at the back of our atlas book. This is the as I said earlier, the introductory part is dedicated to the similar woods that are commercially relevant. And we've picked a sample of representatives. For example, Bubinga has been described very completely. And then the similar woods are like Black Chacate, Ovangrol, Musibi, and Montaigne. We have this very quick and informative form depicting all the other woods, and we have the pictures of cross sections. Once your eyes are trained to recognize and identify woods, you will capture all the differences, and you will see that there are very different woods here, and they can definitely be distinguished from one another, even by simply using this method. This proves that we can use this relatively simple and easy technique, and by using it, the level of accuracy can already be pretty high, pretty satisfactory. We can achieve a level of accuracy in our identification efforts that are already pretty remarkable. And in some cases, they are on the same footing as the level of accuracy of a microscope. For example, oaks. We talked about oaks, so evergreen oaks, white oaks, red oaks. The same level of accuracy in distinguishing them can be achieved by a magnifying lens and applying this method, just like by using a microscope. By using a microscope, you wouldn't be able to tell anything more than just by using the magnifying lens. And so in some instances, the level and the degree of precision and accuracy is very much is the same that you would reach with more accurate and more sophisticated tools. And maybe you can now project the license key, the software license key, and I'm closing my contribution shortly. So is there a tool that guides us on how to identify wood? Okay, I can study the atlas, I can have it as a reference book, but then I cannot browse through the entire atlas and reading all the descriptions in the hope to find the one that that matches with the wood I have in front of me. That's why we have the so-called identification keys. Basically, these are keys that guide the examiner on how to identify. On the left, we have all the complete list of features. First number is number 1, and maybe we can stop on number 5. That's porous ring. If you click on plus, drop down menu opens, and if my oak wood has porous rings, then I can select present. And on the right hand side, the system selects 11 wood species against the 120 of the beginning, so it filters the possibilities, the various options. So we can now go down with our arrow, scroll down again, down again. Here we are. So visibility of rays, visible rays. That's another feature that it's very easy to determine. And as you can see, only 5 species are selected: 2 Quercus, Tech, Ulmus, and Melia azedarach, which is part of the mahogany similar family of woods. So the system allows us, through certain selections that we make, as we observe our sample, the system allows us to be guided in the identification. I only have 5 species here. I can then refer to my atlas, and simply by the physical appearance, I may as well rule out a couple of them. So it's very quick, it's very intuitive, and I can quickly get to a determination. If I have selected some wrong features, I can go back and deselect them, deselect the boxes. So these IT tools, ITTs, are very practical because in comparison to the dichotomy classic identification key, I have a list with a couple of options, porous ring, non-porous ring. Once I've selected it, it brings up another couple of options. And it drills down to when I get to the result. If I get it wrong in one of my selections, I'm completely misled and I can't go back and know where I go when I selected the wrong box. Whereas with the IT-based selection kit, everything is much simpler. You can go by trial and error, but then at a certain point, like the name pops up on the right-hand side of the screen, and with a little bit of experience, it really is a very good guidance tool. Maybe we already have in mind what it could be, but the name just doesn't come to our mind. And by using these combination of tools, we certainly get closer to the solution.
We have a few minutes left, so if you have any questions, it's a huge work. I can see you have a copy of your atlas here. Well, the publishing company was courageous as well, because it's huge book, but I think it's a niche market. Yes, we did it for passion. I think you do these things because of passion. And since I do teach these topics at university, these are the tools I actually need at university. Is it harder to get to Giordano's work? With all the plates, the wooden plates? No, that one was Palutan, the 4 volumes, 5 volumes. I think I have 2 volumes somewhere that I stored somewhere. I have them all, but it was very hard. I'll come and see you at home. I'll pay you a visit. Professor Ruffinato, it was really a journey that is rooted here in the work that we see here at Xilexpo, but wood always carries with it its poetry that we somehow miss. I mean, well, actually, my great-grandfathers were ebony workers, and so I still have some pieces of carved wood, and it's wood that I don't know what it is. I'm gonna come and see you with all my wood pieces so that we can see what they are.